Kia ora and welcome to the workshop 2 screencasts for 161324 data mining. So today we're going to be looking at pivoting. So that's converting data from long to wide or wide to long. It's useful in particular for creating tables. It's also useful for cleaning up data that comes in wide form, but long form is generally tidier. We'll also be looking at joining two data sets together. So we'll be looking at both the role data set that we looked at last time and the schools data set, which has some information on each school. So we're going to be joining those together. We're going to be looking at a real-world data set from the Ministry of Health and how that comes in all its peculiarities, which is often how data comes, and how we can potentially clean that data up. And then we'll be using that particular data set to see if we can reproduce a chart. So I'm going to start by reading in our data. So this loads both the Tidyverse and Read Excel packages, so we'll be using that to read an Excel sheet from Ministry of Health later. So you may have to install that first. You may have a yellow bar up the top here suggesting that you install that, so go ahead and do so now. So here's our role data. We've processed it into our clean data set in the same way that we did in Workshop 1. And today we'll be looking at summarizing using more than one group like we did last time, and turning that into a table with pivot wider. So the idea with is that data through to today has been tidy in that each row consists of a single observation and each column is a separate variable. So in our clean data, let's have a look at it, each row here is telling us the number of students at a particular school of a particular gender in a particular ethnic group at a particular year level. So that's a single observation. It's not an observation for a single student, it's an observation for a group of students that satisfies some criteria. And the way it's set up, we can filter, we can mutate, we can produce charts and so on directly because the data are tidy. We'll be looking at ways to make this data untidy. For example, we'll be looking at producing tables where the same variable is spread across multiple columns. Okay, so an untidy way of representing this data might be, instead of having the gender column, we could have two columns, one for the count of female students and one for the count of male students. So we'd have the same amount of data, we'd have fewer rows because we wouldn't need to duplicate a row for each for A1 school limited, so say take rows 4 and 5 here, they are A1 student limited, European level 5, all the data is the same. If we took the female and male rows here and combined them into one, into a column for female students and a column for male students, you'd have a 2 and a 1, you'd just have a single row there. So we'd have fewer rows, same number of columns, which seems more efficient, right? But it's not, and the reason it's not is if we wanted to then produce a chart for the number of students or produce some code to total up the number of students, we would have to be constantly recombining those two columns of male and female in order to put them on our chart. So say we wanted the count of students to be on the y-axis, then we'd need a single variable for that because ggplot requires a single variable. You can't pass two variables to the y-axis. If we wanted to do any group by and summarizing type thing, then we would have to do separate summarizers for each of those two columns. So it would be twice as much code to write. So there's an advantage to having it in long form like this, even if it's perhaps slightly inefficient in terms of space. Okay. So let's have a look at an example where we might want the data in other forms. So we did this one last week where we produced this table of the number of students, total number of students by ethnic group and gender. So we can see that we're doing that here by just reading the code. We're taking our clean data set, we're grouping it by ethnic group and gender, and then we're computing students as the sum of students. So that'll be the total number of students by ethnic group and gender. But this isn't particularly easy for us to read as people because we'd ideally like to be able to compare within ethnic group across the female and male, and also within gender across the ethnic group. So we might want to be comparing these sort of numbers which are interleaved, which is somewhat difficult to do. So it would be better to present this data with separate columns for female and male, so number of female students, number of male students, which would get rid of the gender column. So we'd have the same number of columns, we'd have ethnic group, female students, male students, but we'd have fewer rows, right? We'd just have a single row for each ethnic group then. And we can do that with pivot wider. So pivot wider will take a column to take the names for the new columns from. So we're going to be taking our new column names from the gender column, and we're going to be taking the values to fill that column from the students column. So let's run that and have a look at what it does. And there's the table that we might want to have. So now we can easily compare within an ethnic group just by comparing the numbers across the row, within a row, and we can easily compare down as well, the columns. So this is more is sort of a better tabular form, but it's of course harder to process. If we wanted to then do a chart of this, we'd actually need it in the long format first in order to supply again a single column to ggplot. So let's have a go at some of these. Probably shouldn't be typing out that by hand, should I? Should be using the key shortcut. Okay, so we're going to take our clean data and we're going to group by gender and year level, summarize the number of students, okay, so there we go. So now we've got year level, gender, and number of students, so we're going to have males showing up here, and now we're wanting to convert that to a table, and so we're going to want level down the as our row names, if you like, and gender is going to be our column. So we're going to take our new column names from the gender column and our new values from the student column. So we're going to pivot wider, and our names are going to come from our gender column, and our values are going to come from our students column. Okay, and that produces that table there, which is what we want. Create a table with the number of each ethnic group in each year level. Well, it's the same type of idea. We're just going to group by different variables. So I'll copy that code. So this time we want ethnic group by year level. So we're going to want ethnic group in here. Right. So we've got ethnic group by year level, total number of students. And so now we're going to want to have one of these as rows and one of these as columns. There's more year levels, so they'll probably be better as rows. So when we pivot wider, we're going to go from the ethnic group. And there we go. So for each year level, we have ethnic group as columns, and we've got the number of students. Try adding a total column to the ethnic group by gender column. So there's a couple of ways we could deal with that. So let's grab our ethnic group by gender column. Sorry, that's ethnic group by gender, which is this one up here, isn't it? So let's grab that code. We'll do it all in one so that you can see how it's going to work generally in practice without sort of temporary variables. So here would be we'd have a pivot wider here, wouldn't we? So here is our table, and now we want to add a total column. So there's two ways we could do it. Okay, so method one, operate on the table. Right, so we could add a mutate here, where total would just be female plus male. Okay. Now the disadvantage of doing it this way is that is kind of twofold. The first thing is we had to know what the name of these columns were going to be, and I don't have autocomplete here because ggplot doesn't, because dplyr doesn't know, because it would have to execute the pivot wider in order to figure out what those columns names were. And dplyr is lazy; it only executes things once it's finished. Part of the reason for that is that you know, if you were operating on a database that's not on your machine, then you want to do all of this on the database first rather than pulling down all of the rows onto your machine. And of course, if it's executing sort of line by line, then some of these databases may be very, very large, and that's going to be super inefficient. And the other thing is that it's not too bad here because we only have 2 to add together, but what if we had 6? So what if I wanted to do that to this table here? I would have to type all of these out manually, and there's a good chance that I might mess that up or miss one. And then my total would look, so say I missed the international fee paying, my total would look almost right because these numbers are small, but wouldn't be correct. Okay. So method 2, which is favored, is operate on the tidy data set, then pivot. Okay, so the idea is that we produce the data that we're going to need to do so. So here is a data set where we have the number of students by ethnic group and gender, and you notice it's already grouped by ethnic group. So we can compute the total number of students per ethnic group, which is what that total column is giving us, total number of students by ethnic group, directly on this table just by doing another sum. So we do a mutate because we're not wanting to summarize, because we need the totals broken down by ethnic group and gender for our table, but we need the total as well. Okay, so this is very, very easy to do. Notice that I don't care what the levels are in between of the gender variable, so I could write that same code and it would work if I grouped by year level instead of gender. I would just change level to there, right? Get the same thing. There's the total of Asian students, same total as I got when I grouped by gender, right? So it's much easier to transfer this code, but then I need the table, so I'm going to pivot wider. Our names from is again going to be equal to our gender. Our values from is going to be our students, and we get our table. The only disadvantage here is that our total column is not really where we'd want it, so we'd want to relocate that column at the end. So relocate can be handy for that. We could also use select to pull the ethnic group female and male out and then put the total on the end. So if we have a relocate, we're going to be total, and it's we can kind of infer from the pop-up there that we probably want to specify the after, and I'm guessing we can just put infinity. No, we can't. Let's have a look at the help there. Let's see what it says. Destination. Supplying neither will move columns to the left side. Supplying both is an error. What is our... there we go. After equals last column. There we go. That would be an easy way to do that. Okay. Right, and the last one, try creating a table. With the percentage of female and male students within each ethnic group. Right, so this is a similar thing as we did here. Let's grab that. Right here we had the, we added a total, but this time we don't want to add a total, but instead we want to, let's leave that there. we want to convert these to percentages or proportions, I suppose, within each ethnic group. So again, we're already grouped by ethnic group here, so we could add, we could mutate the existing column Right, so within this mutation, that sum is going to be done within group because we're grouped by ethnic group, and so we get the proportion. Okay, we could multiply it by 100 to get a percentage. Okay, and maybe we could round it. To say 1 decimal place. Oh, interesting, that didn't work. Why didn't that work? I don't know why that doesn't work. Some weird base pipe thing maybe? Interesting. Not sure. Anyway, let's move on. We won't spend time trying to figure out that. I might have a look at that later. Okay, so now we want to use the percentage column to do our pivoting. So our names from is our gender, and our values from is our percentage. Okay, and we get this strange looking table here where we have some NAs. It hasn't compressed this down, and the reason is that it's done the pivoting, i.e. it's created our new columns female and male, and it's filled them with the percentage column, but there's another column in the data that is still unique within gender ethnic group, and so it's had to, it couldn't collapse the students column down. In fact, we don't want the students column, right? So we could perhaps select it away, and then we're okay. So if you do get odd situations when you pivot wider and you get a bunch of NAs, it's usually because you've got another column there that is unique to the grouping that you're trying to break with the pivot wider. Obviously, you could do that the other way as well. So you could sort of do it this way, right? So you would just mutate the female column is female divided by female plus male, and the male column is the male column over female plus male. Notice that when you do that, you'd have to introduce temporary variables though. So it would be a bit messy, and again, you have to specify all the different columns, whereas this method would also work if I just switched this straight away to level. Then everything works. Okay, so there's the percentage of Asian students in level 1. So this sums to 100 across the column, and of course I can reverse that if I want. So if I wanted the percentage of ethnic group by level, I would go that way around. Well, no, I would have to reverse these, wouldn't I? So that the groupings are the right way around when it computes the percentage there. Okay, so the advantage of doing it when it's tidy is it's tidy, so you can do it without having to reference the subgroups and so on. Let's get this back to what it was. Okay. So back in workshop 1, we produced a chart that looked a bit like this, where we had the breakdown of total number of students by level, broken down by female and male. And so we see this interesting reversal in the pattern, in that there's more males than female all the way through to year 13, and it gets close to the same at year 12. So so it might be interesting to see if this holds up by other subgroups. So for example, we could look purely at the European group and then at the Asian group separately using a filter, and produce two separate plots. So you can see that this first one, we're taking just the Europeans, then we're executing our cleanup and plotting it. So here's the chart for Europeans. And sorry, that's the chart for Asians, and here's the chart for Asian student, and here's the chart for European students. So the chart for European students has largely the same pattern. It's the largest ethnic group in this data, so it would make sense that it has a very similar pattern. And the chart for Asian students is somewhat similar. It's not as extreme. So for example, the difference at year 13 is there are more female students than male, but it's not as big a drop-off as it is in European students. But the problem here is we've got two separate plots, right? So ggplot can do that grouping for us by using faceting. So we've got facet wrap or facet grid. So here we produce a plot. So we're going to create a data set which is grouped by ethnic group, level, and gender. And then we're going to plot that faceting by ethnic group. So we've added this line here. So it's going to do a plot of year level on the X, total number of students on the Y, split up by gender in terms of the fill color, dodging it so that they don't stack, and then we're going to do a separate chart for each ethnic group. So those are the two we had before. Notice that by default it puts it on the same axes, which in this case is possibly not useful because there's very different numbers in each group. Like we can't even see the pattern in the international fee paying, really. We might try and split that up with different x-axes. So let's redo this chart. So let's have a look at the help for facet wrap. So we can see down here, we can change the number of rows or number of columns that it uses. 3 by 2 is probably fine. Scales equals fixed. Let's read about that. Should scales be fixed? That's the default. Free or free in one dimension. Free X, free Y. So we want to free the scale in the Y direction. There's not much point freeing it in the X direction because the scales on the X are all the same anyway. So we go scales equals free Y. And so now we've got a separate scale for each of the groups. So you can see that international fee paying obviously has a very different pattern than the others because, of course, these are students that are coming to New Zealand to study, which typically happens at high school more than at college level rather than at primary school level. So you get this sweep in the distribution. And interestingly, there's more males than females that are doing this. Whereas in all other groups, we've got this pattern of more females than males at year 13. Okay, so instead of colouring by gender, we could produce separate plots by both gender and ethnicity by supplying both to facet wrap. So let's alter this plot. Right, so instead of colouring by gender, we're going to supply both to facet wrap. And we get this chart here. So now we've broken down by ethnic group and gender, and we've got a separate chart for each of them. Now this is a little bit messy because now the amount of space taken up by the labels is very high. It's also not spacing them very nicely in that we've got Asian students, female, male, European students, female, male. It'd be nice if all the females were grouped together and all the males were grouped together in some way while also grouping the ethnic group together. So we could sort of perhaps artificially do this by specifying the number of columns. So if we specify just 2 columns, then it would have to put female and male and then cycle round so all the females are on the left and all the females on the right. You can see the issue here is that with the default size of that chart, which in case you're interested is specified by the fig width and fig height, so I can change that here. So I could make the fig width say 7 and the fig height say 10. These are in inches, which is a very strange measure, but there we go. So you can mess about with that if you wish, and get a better looking chart. But again, a lot of space is taken up by these labels, and of course it's the same label at the top here for ethnic group. So the ethnic group could actually is the same for that row. So we could actually write ethnic group down here, so Asian, European, international fee paying, and so on, and that might be better. And that's what we do down here in facet grid. So let's do the same plot with facet grid instead of facet wrap. So facet grid is for splitting up a plot by two variables at once, right? So now when you have facet grid, you have to specify a variable for the rows. So we're going to be, perhaps we'll do gender as the row. So we'll flip that same plot round, and the columns is going to be ethnic group. That's got to be in vars as well. We've got some very strange error there. Let's just rerun it again. There we go. Okay, now when we do this, we can't change the scale per panel because it's a grid. So we can only change the scale for the rows. So if we tried, for example, using free Y for the rows, then we get something that looks very, very similar. You can tell that the scales are actually different for row 1 and row 2 because row 2 includes the 20,000, whereas row 1 doesn't, because there's more males than females at year level 7 in the Europeans. But we can't change it per panel because we're in a grid, right? We could change it per panel here in this facet wrap. Okay, but there's another way we could do that same chart, is that we could convert everything to proportions first, right? Because the scale here doesn't actually matter. It doesn't matter so much. What we're interested in is the distribution. Okay, so we could get our ethnicity by year, by gender. Right, so that is broken down. We're grouped by ethnic group and level. We could switch the grouping to ethnic group and gender instead. So that we are, when we convert to proportions, we get the same. We get a proportion for within ethnic group and gender. So let's okay, so now we've got that proportion, and then we could plot that instead on the y-axis instead of total. Okay. And so now we can see this, the shape distribution. And perhaps we might want to get rid of the international fee paying students as well. Because we know they are quite different, don't we? And there we go. Okay, obviously we could still add colours if we wanted to. So we could still fill by gender. You know, if we do want different colours, and we could turn off the colour guide if we wanted to as well, by specifying fill equals none. You know, if we wanted different colours or whatnot. So that's the other way to do that. So just realised I've actually deleted the other one. So let's go back to the one we had before as well. Get rid of all that. Don't really need to pipe anymore. We could do, of course, it doesn't really matter. And we're going to fill by our y is going to be our total. And we don't need to change the scale. In fact, we don't need to change the scale on either of them, do we? There we go. So there's the first chart we had, and there's the cleaned up one. Okay. So now we're going to have a look at the schools data set. So you can see that we've got a bunch of information for each school. So perhaps we'll click on that. Okay, so we've got the name of the school. So we've got one row per school, and then we've got things like the sector, the type of school, whether it's a state school or a private school, whether it's co-ed, male or female only. Affiliation, I think, is something to do with whether it may have some religious affiliation. So there's Catholic schools, for instance. Then there's a Kura type, so is it a Kura school or not? There's the regional council in New Zealand, and then there's the territorial authority, which is a finer level. So I think there's about 20 odd regional councils, whereas there's about 70 odd territorial authorities. And within Auckland, because Auckland's a very large territorial authority, it's been broken down by ward. So there's probably about 150 of these or something. Okay, we could find out, of course. So count the territorial authorities. There's 88. Okay, so not as many as I thought. And count the regional councils. There's 18. Okay. Okay, so let's have a look in this data set. So how many schools are there in the Palmerston North Territorial Authority? So let's filter down to Palmerston North. And then, well, that's probably all we need to do, don't we? There's 44. Okay. Of the schools in Palmerston North, how many are co-ed, single-sex, or single-sex girls or single-sex boys? So let's do the same filter, and then we'll just count by school gender, like it recommends. Okay, so there's only one single-sex boys' school, that's Palmerston North Boys High School, and one single-sex girls' school, Palmerston North Girls High School, and the rest are co-ed. And lastly, we're going to produce a chart of the decile distribution of schools in Palmerston North in the primary sector. Right, so we're going to get schools in the primary sector first. So maybe that's just primary, is it? Yep, so there's 33 primary schools. And then we probably have the decile. Yes. Okay, so we're going to throw that into ggplot, and we'll do a column, well, we'll do a bar chart, won't we, because we haven't summarized the number of deciles. So we'll do a bar chart, because that'll do the summary for us by decile. So there we go there. So that's the decile distribution of schools in Palmerston North. Notice the axis is an ideal here. A couple of ways we could deal with that. We could convert it to a factor, and it would automatically know that it's counts. Alternatively, we could change the axis to scale x discrete. Not values, breaks. There we go. Oh, it's not discrete though. I think it's because it's interpreting it as continuous. Yeah, there we go. Okay. Right. So now we're going to take that schools data set, which has information about region and decile and a bunch of other things, and we're going to join that to our role data set so that we can transfer that information across to students. So we do that with a left join. Okay, you can see that it's joining by the school variable, because that's the common key between the two. You can see that I get the role data all the rows in the roll data, remember, with the left join, and then you get anything that matches from the right data set. So now we've got all of these school-based columns, which are of course duplicated because the school is the same. Okay, so we've got all of this information that we can then apply to our schools. So we can now do other computations, like using the school information and the student information combined. So for example, how many students are there in each regional council is we just group by regional council, and then we can sum up the number of students. So there we go. We can see there's 280,000 students in Auckland. And so, for example, in the Manawatu Whanganui, where I am, there's 41,000 school students. How many girls and boys are in schools with a religious affiliation? So we're going to have to look in the data set and see how we can get that. So remember, there's an affiliation column. We can see that in the schools data. There's the affiliation, and we've got affiliation type. So I'm guessing it's one of these columns. So there we go. We can in fact see it directly. But if we couldn't see it directly, you know, it wasn't on the first page of our information, how might we find that? Well, one of the ways to do that is you can use count by the affiliation, for example. So we could try affiliation type. So we can see that there's no affiliation, organizational affiliation, or religious affiliation. Options. We could also have a look at the affiliation variable as well to figure out what it is. So you can see that this is telling us some information. We've got some weird macron issues here, which is interesting. So it's telling you what the affiliation is, and then there's not applicable, which will be the no affiliation thing. So you can see that the largest affiliation is Catholic schools. So we can see that affiliation type is what we need, and so now, variable and condition, and then filter. So all data we're going to filter. Affiliation type is going to be religious affiliation. Copying and pasting to make sure I don't make a typo. So there's the all the rows in the data from schools with religious affiliation. You can see that that's likely correct. And then we want to know how many girls and boys there are, so we're going to be grouping by gender and summarizing. So there we go, 57, almost 58,000 females and 55,000 male students. And lastly, we're going to produce a chart to compare the ethnic makeup of secondary schools in decile 10 versus those in decile 1, excluding international fee-paying students. Right, so we've got a bunch of things to do here. So we need to exclude international fee-paying. So that's the ethnic group. Check that that's right. Yep, we've got fewer rows than we had before. Secondary schools only, so could maybe add to that same filter. So we want our sector. Is that what we want? Possibly. Let's check though. Secondary. I guess potentially we're missing some composite schools. I don't know if any of the other information is useful for that. Let's have a check. I think that's probably the best we have. Yeah, so the composites are sometimes secondary. So I think the idea is we're only wanting secondary. So I think that that's okay just to use that. So let's do that filter. So sector. Secondary, so that's only the secondary schools, and then we want the decile to be either 1 or 10. So I'm using the in for that, and I could check The decile is 10, and there'll probably be some 1s in there as well if I go far enough. There we go. Right, so that's, I think, the filtering. And now we want to compare the ethnic makeup. So we want to know the number of students by each ethnic group and decile. So we're going to want to group by ethnic group and decile. I'm going to go that way around just in case I want to convert it to proportions within decile later. And then I want to summarize total number of students. So there we go. There's the decile 1 and decile 10, and then I can just plot that, right? So I'm going to use a column plot because we already have the number that we want to put on the y-axis. So the x-axis I'm going to put ethnic group, and the y-axis I'm going to put students, and I might facet by decile. Whoops, I spelled that wrong, didn't I? So there we go. So you can see that there's a fairly stark difference between decile 1 schools and decile 10 schools in terms of their ethnic makeup. So you can see that decile 10 schools, so these are schools that draw students from areas that are typically more wealthy, are Asian and European. And then there's students that draw schools that draw students from places that are generally less wealthy, which are Māori and Pacific students, which tend to have more Māori and Pacific students in them. So there we go. Okay, and the last thing we're going to look at is on tidying data, and we're going to look at a real life data set from the Ministry of Health. So we can click on this link and find it. So here it is here, the national immunisation data, and we're trying to find the 1st of July to 30th of September data set from 2021. This one here. Okay, so that's downloaded. So let's save link as maybe. Pop it in here. I'm going to put it there. Okay. So we might want to load it into Excel. So I'm going to bring it, sorry, that's the wrong one. So I'm going to bring that up. So here it is here. So this is the data from the Ministry of Health, and you can see that there's two spreadsheets. There's one on social deprivation. So we have the milestone age of vaccination. So there's different vaccinations you have at different ages. We've got it broken down by DHB. So we've got a national total, we've got DHB, and then we've got total immunised here. And then we've got it broken down into New Zealand deprivation deciles, which potentially reflects things like access to healthcare. We've also got it broken down by ethnicity. So we've got, again, the total, and then we've got it broken down by separate ethnicities. You can see that this sheet is not machine readable. It's got a bunch of junk in it. We've got a title here. We've got data spread across multiple columns, so that the count is here and here and here and here and here and here and so on. We've got computed things which are useless to us because we can just compute them directly from these two numbers. We have replicated rows, which is okay, but we've also got a total row. So that there is just the sum of, so that number there is just the sum of those ones, and so on. So we're going to have to filter out a bunch of stuff. And this is often how data comes to you, because this is, potentially useful for a human eyeballing this data, thus all the colors and whatnot, right? But it's no good for a machine to read. And it's no good for us to be able to process this, produce charts and so on. would be a bit of a nightmare using these data as it is. So we're going to look and see if we can attempt to clean this up with code. Okay. Oh yeah, something I didn't notice is there's a key down the bottom. So there's all this extra junk down the bottom telling us what everything is. You can see there's some issue with, we've got some dashes here, which are, what are they? Are they missing? Maybe. We've also got this NS, which is data not shown to protect privacy. There's fewer than 10 in the group. Although interestingly enough, they have given us the proportions, and if you know anything about proportions, you can see this is 88.88888888%. So we know that the denominator is likely to be 9 or 8. So that's likely to be 9 and that's likely to be 8. So they haven't done a great job of suppression here. In some cases anyway. Like in the 100%, all you know is those two numbers are the same. You don't know what they are. Okay, so let's have a look at how we might read this in. So what we're doing is we're downloading the file directly using code and we're saving it to our folder, and then we're running Excel sheets to find the name of those two sheets. So you remember there was a deprivation sheet and an ethnicity sheet, and so we're going to be reading in the ethnicity sheet, and you can see that when you take a look at that data, this is what you get. So we've got 160 rows and 20 columns. You can see that the name of the columns are, we've got this giant column name here, which of course was the title cell, and then you've got a bunch of columns that aren't named correctly. We've got a bunch of junk. So the first thing we notice is that we should skip several rows at the start of that data set. If we go back and have another look at it. Right, we should skip row 1, row 2, and row 3, and then maybe start there. Let's see how we get on. So that's what we're doing here. Okay, so now we have the milestone age, we've got the DHB of residence, and we've got a bunch of extra columns for all of those different eligibility. Unfortunately now we've lost what these columns mean because that was described at the row above. So the names aren't useful, so we're going to have to correct all the names up. And we're going to keep some things simple by ignoring ethnicity here and just looking at totals. So we're going to look at just column 1, column 2, column 3, 4, and 5. So we're going to ignore the separate ethnic groups which are over here. Okay, so now we've cleaned them up by using a numbering technique for picking out those columns. So milestone is going to be column 1, DHB is column 2, and so on. So select can use numbers to reference columns, which in this case is probably the only thing we can realistically do. So now this is something that's reasonably clean. We do have this these title rows here, which have NA, and there'll be another one further down, perhaps. I don't know. No, there's not another one. We've got a national total here, which we'll need to get rid of. And then we've got all this junk down the bottom that we'll need to get rid of. So we want to filter a bunch of things out. So we're going to filter out, for example, the all milestone coverage. Notice it's spelt wrong. So we're going to filter that out, and then we're going to filter out the national total row as well to get rid of those. And then after that, we're going to have a look and see how many rows we have per DHB. So you can see we have 7, and how many rows we have per milestone, of which there's 7, and we have 20. And there's 20 DHBs. So it looks as though we've got 1 row per milestone and 1 row per DHB. So this is cleaner. So let's perhaps have a look at the cleaner data set. So this looks quite good. One thing I noticed is the way these numbers are formatted. So the eligible numbers are formatted to the left here, whereas the immunized numbers are formatted to the right, as are the proportions. And I think that's because somewhere in the eligible numbers we had some character strings. And so it's converted those numbers, which are in fact numbers, to character strings. So we're going to have to convert them back, which is what this next set of code is doing. Okay, so now you can see that it's of type double, whereas before, if you had a look at IM cleaner, you can see that it's of type character. Okay, so at this point, things look pretty good. One thing we could check though, to make sure that these numbers did transfer over correctly, is we know that the proportion column should just be immunized divided by eligible. So we could check that by computing it ourselves, just to make sure that we haven't, because we've converted this column from character to numeric, maybe something messed up when we did that. It's a useful check to do. Okay, so we're going to compute this ourselves. Okay, so I'm just executing this first set of code, and I can just see by eyeballing it that these numbers look very close to being the same. In fact, they look the same to me. But they might not be equal. Let's check. So one thing we could check to see whether they're equal is to check whether a prop check is equal to proportion. So we want to find where they're not equal, don't we, really? They're not equal in 18 rows. Yet when I look at these numbers, they look equal. And that's just due to how numbers are stored in a computer, and in particular how they're then transferred to an Excel sheet compared to how they're computed directly from those raw numbers, right? So a floating point number is stored using bits on your computer, so it might be 64 bits usually, it might be 128 depending on your system and how it's configured. And so they're not stored precisely, they're stored to sort of about 16 decimal places or thereabouts. And then that representation has to be written out to an Excel file where it could perhaps be converted to a character string or some other data type and stored in the file, often as a character string, I think, in Excel sheets. And that may include a different rounding. And then we'll have to read it in from that character set and again store it in that 64-bit floating format. So there's room for very small rounding issues. And so that's why we tend to use a different method to do the check. So here, I'm checking whether the absolute value, right, so convert it to a positive number, of the difference between these two things. So I compute prop check minus proportion, right? So that'll be the difference between these two numbers, which we would expect to be very small. We convert it to absolute value just so that it's positive, and then we check whether it's greater than some small number. So this is 10 to the minus 6. And we can see that there's no rows returned where the difference between prop check and proportion is bigger than 10 to the 6. So we can be confident that we have correctly read in that data set. So now our goal is to use the imclean dataset to reproduce this plot. So there it is. So this is a plot that that shows us each of the milestones, 6 months, 8 months, 12 months, 18 months, and so on, the percent immunized for each DHB, and compares it to the goal. So the goal for these for immunization is to hit 90% for each milestone within each DHB. And you can see that it's colored pink if they haven't yet reached the milestone and gray if they have. So we're going to want to try and reproduce this plot using these data. We might want to sort of save that chart. We'll perhaps load it into a browser. So all I did is copied and pasted that into a browser window so that I've got it there, just so that I can compare it at each time by switching windows. Save me scrolling up and down so much. So we want to reproduce this chart. So what I notice immediately is I've got DHB on the y-axis, I've got the percent immunized, so that'll be proportion on the x-axis, and I'm faceting by the milestone. Okay, so if we have a look at that IMM clean data set, which is the one we're going to use, you can see that we're using the proportion column that's on our x-axis, the DHB column on our y-axis, and we're faceting by milestone. So I'll start by doing that. So I'll take the clean data set, I'll throw it into ggplot, do a column chart where the x is going to be our proportion, our y is going to be our DHB, right, and we're going to facet wrap by our milestone. And you can see that I've got something close to the final chart already. Obviously it doesn't look very attractive yet, but you can see that I've got the basic bones, right? And that should always be your goal if you're trying to reproduce a plot, is to get the basic bones up and running as soon as you can, so that then you can just focus on refinement. Okay, so we've got a good start here, but what we notice is that so the first thing I notice is that I have the 5 years milestone here, but not on the chart that we're trying to reproduce. So we could filter that out. So perhaps we could do a filter where the milestone is not equal to 5 years. Okay, so that looks close. So the other thing I notice is that we've got a different order. So the order of our milestones is different. So on the actual plot, it's in sort of numeric order, which kind of makes sense, right? So we go from 6 months all the way up to 54 months, whereas we're sorting alphabetically in our current effort. So we're starting with 12 and 18 months. So we need to reorder such that 6 and 8 months are first. So let's try that. So we're going to have to do a mutate. We've got a wee hint here. In that the relevel command is useful for redefining the order of a factor variable. So let's try that. So we want to re-level the milestone. So let's have a look at the help there for factor relevel. So it takes either a function or character levels. So if it's a function, we don't know. Any levels not mentioned will be left in their existing order after the explicitly mentioned variables levels. So if we start, if we specify 6 months and 8 months, then everything else should be after that. So we want to put 6 months first, then 8 months, and then everything else after that. Right, so they're in the right order now. So the next thing I notice is that our DHBs are in reverse alphabetical order. So this is because, so they're actually in correct alphabetical order on what we have, in that Auckland is starting lowest on the y-axis, and then increasing alphabetical order is increasing up the y-axis, but we want it the other way around because that's how humans read. So again, we want to do another mutation here of the DHB, and we're going to use factor reverse as the hint, okay, which just reverses the order of that variable. So there we go. So this is looking very close now. So what else do we need? Well, we've obviously got the colors. We've got some labels to fix. Perhaps we might look at the colors first, and then we'll look at cleaning up the labels. So we notice that it changes color if the percent immunized is bigger than 90%. So the easiest way to get this done is to add a new variable to our data set such that it's set to true if that goal is reached, so the proportion immunized is over 90%, and it's set to false otherwise. So we might call this goal reached or something, and we're just going to set it based on the proportion bigger than or equal to 0.9, 90%. And then we can then fill by the goal reached, spelled correctly. And so that looks very similar. So the colors aren't right, but it is the same pattern. Okay, so now we're just cleaning up. So we've essentially got the same chart. We could add a vertical bar here, but we've got to clean things up a bit. So what do we notice? So we're missing the DHB label in our final chart because we can see that these are regions or DHBs anyway. We want percent immunized along the x-axis. So let's fix that up with some labs. So to get rid of the Y label, we're going to set it to null. The X label is going to be percent immunized. So that's looking good. Now we need to convert the x-axis to percentages. So let's do that. So we can use scale x continuous for this. And we can switch the labels. So we could just Google that, right? So let's Google it. So we go ggplot2, changing axis to percentage. Here we go. Let's have a look. So here we've got this bar chart. Here we go. So scale Y continuous labels scale percent. Interestingly, it's actually the x-axis. This is probably quite old, this guide. Let's maybe switch back and look at the Stack Overflow answer instead. Okay. So we could use the labels argument. Okay. So let's have a go with this one. So scales. See if that works. Yes, hooray. The other way, I think the sort of the correct way to do it is label percent. Now I think is the way to do that. This is sort of the preferred way. And so we've got our percentage label. We also want to perhaps extend it to go up to 100%. So we may want to change the limits to go 0 to 1. There we go. We want to get rid of the guide. So we can turn off the fill guide. There we go, that's looking good. And now I think the main thing is the colors. Oh, and that vertical line. So we're told what the colors are. So the colors are these two. So we could go use scale fill manual for this. And we're just going to use the two colors specified. Excellent. And then it also notes that they're slightly transparent. So let's add that little bit of transparency to our geom col. There we go. What else? We need the vertical line. The line is at 90%, so we want to know how to put a line on a plot. That doesn't depend on data. Instead, it just depends on the x variable in this case. And so the way to do that is with geom v-line. So we want a vertical line where we just specify the x-intercept. So the x-intercept is going to be 0.9. There we go. Now I think if we look carefully at the plot, I suspect that the line is underneath the bars. We can see this here. The line is a slightly different color where it's gone over. So let's change the order of those layers so that the bars go on top. Perfect. That's matching really well. And really the last thing is just the theme. So we're told that we use theme minimal, so we can add that on. And there we have a chart that looks very similar to the one that we're trying to make. Guess perhaps the line width of that line might be a bit smaller. Maybe. How do we do that? Is it line width? Didn't seem to do anything. Let's have a look at John V line. Yeah, so what are our other aesthetics? So I'm just Googling line width aesthetic. Yeah, so it is line width. Let's just change it to a much smaller number and see what happens. Ah, there we go. It is actually working, so it's mostly disappeared there. So we'll make it maybe 0.1. There we go. That looks quite nice. So there we go. So the only real difference now between the figure and our representation of it is the size, right? I mean, we could perhaps try and match, but it really just depends on the computer that it's generated on. So maybe we'll just make the fig width and height a, say 10 and 8, see what happens. Okay, so that's maybe a bit small. So maybe it's 8 and 6. So it sort of depends on a whole bunch of stuff, which is the DPI, so dots per inch of the of your computer screen, the size in terms of inches, and many other things. So maybe it's supposed to be 7 and 5. There we go. That's probably not too far away. If I scale it down a bit, that's pretty close. Okay.